friends, welcome to CEC lectures. Myself Dr. Preeti Jagmani from Department of Computer Science, Aribhat College, University of Delhi. So, in this series of database management system, my today's topic is transaction is SQL, and as you have seen in the previous lecture, we have seen about in many of the previous lectures which we have already covered, we have seen the structure of the database at the logical level. We have also seen the view levels, and now we have seen many queries which are kind of insert, update, and delete. Now let us try to see what actually a transaction is in what actually a transaction is in SQL, and also how are we going to treat with this transaction and why this transaction is important. So let's say we have a sequence of query, we can say, or we can have a sequence of update statements, and the SQL standard specifies that a transaction begins implicitly when an SQL statement is executed. So, for example, we are going to ask for an update for the salary, and we are going to increase the salary of the instructor, all the instructors available in a relation by, let's say, 10%. So, for that particular scene, we are going to fire an update query, and this kind of the SQL says that the this updation, which I have given as an example of incrementing the 10% salary of all the instructions, this is we can say is recognized as a transaction, because the transaction, as per the SQL standards, the transaction begins implicitly when an SQL statement is executed. Now, it's not about only the execution of the query. SQL statements must end the transaction, and in case of ending the transaction, we can either we need to perform the two actions, or two actions, any one of the two actions has to be performed. One is either the commit, another one is the rollback. So, some in some of the literatures you can say either the commit work or the rollback work. These two kind of we can say actions are there which should end the transaction. One of them should end the transaction, and the term work here is optional, and now onwards we will be either talking about the commit or the rollback. So, a SQL transaction starts with when a query is being executed, and the SQL statement must end the transaction either with the commit or with the rollback. Now, let us try to understand what actually this we can say what is the meaning of commit, or what is the meaning of rollback. So, committing a particular transaction or committing the current transaction, why I am saying current is I will be telling you in a moment. So, committing the current transaction is about making the updates performed by the transaction permanent in the database. So, for example, transaction has performed some we can say updates, and that update is, or that particular update is not becoming permanent in the database unless we commit that particular work. So, for example, it is kind of saving your work, and after the transaction is committed, a new transaction is automatically start. So, for example, let us take, in order to understand this commit and the rollback fundamental, let us take the example of an account transfer. So, for example, an account, let us say account A is being kind of debited by 1000 rupees, and that 1000 rupees is being transferred to an account or credited to an account B. So, this is a complete transaction, but this complete transaction will be saved permanently in the database when this work is being committed. So, the commitment of work is actually important in order to kind of store the transaction permanently in the database, and after this transfer from A to B is completed. So, transfer from A to B will say that kind of deduction of rupees 1000 from the amount which is available in A, and addition of that particular 1000 into the amount which is available in B. So, that whole process is going to take place, and if we want to make that transaction permanent in the database, that we need to commit that work, and after the after a transaction is being committed, another transaction which will follow will be a kind of, we can say, a new transaction. Another term which I was talking about is the rollback. Rollback causes the current transaction to be rollbacked, that is, it is going to undo all the updates performed by that SQL statement in the transaction. So, for example, we can say that this particular example we are going to take, if that transaction has happened as it means it's not committed yet, the transaction has happened, 1000 rupees from A has been deducted and it has been added into the account balance of B, but the transaction is not being committed, instead it is being rolled back. So, in case of rollback, the database is stored, the state of the database is restored to what it was before the first statement of the transaction was executed. So, for example, I want to we can say roll back this particular transaction. That means in this situation the previous state, the state which was available with database before the transaction is started, that means again the a sum of 1000 rupees will be deducted from B and added to A. So, A and B will, both the accounts will now restored their original state which was available to them before the first statement of the transaction was executed. So, actually your rollback is kind of, we can say, undoing the changes, and your committing is kind of saving the changes. So, for example, in terms of document, if we talk about, commit is about saving the changes to a document that is kind of being edited. We are in a process of editing a particular document, and if we want to save the changes, we generally in MS Word we take it as Control S, and here we will in SQL we will say commit. And rollback is compared to quitting the edit session without saving the changes. That means I am just closing on the pressing the close button, and whenever it is asking you want to save your work, and I am saying no. So, that is the rollback. Rollback is quitting the edit session without saving the changes. But please remember that once the transaction has executed a commit work, or once the transaction has been committed, it cannot be rolled back. That means once a transaction has executed commit work, its effect can no longer be undone by the rollback work, and this is what actually happens in our we can say documentation also. Once we have saved that, once we have saved the changes, and even now if we are quitting the session, those changes which are saved permanently in the hard disk. Now, why do we need this, the concept of this transaction and the concept of commit or rollback within this transaction? Now, this try to understand that this is very, very important, because the database system guarantees that in the event of some failure, such as error in one of the SQL statements, it could be a power outage or it could be a system crash, the transactions effects will be rolled back if it has not yet executed the commit work, or in case of power outage or other system crashes, the rollback occurs when the system restarts. So, for example, we will take that example of 1000 rupees transaction, and let us try to understand the situation. So, for example, in this whole transaction of subtracting rupees 1000 from the account A and adding that 1000 onto the account B. Now, let us say something has happened in the between, and 1000 from account A has been deducted, and then immediately then there is a power outage or there is a system crash, and that 1000 from account A are not yet deposited in account B, and your system has been crashed. Now, what will happen? Now this is going to, we can say, leave the system in an inconsistent state. For example, before the transaction, the amount in both the accounts, let's say, was kind of in account A it was 2000, in account B it was 1000. So total it was 3000. Now what happened? From account A 1000 has been deducted, 1000 has been left there, and B is still left with 1000 because that has not been added to the B, and your system crashes. Now after the system crash, if these transactions and rollbacks are not there, the system will get up in a situation in where your transaction A has your account A has 1000 rupees, your account B also has 1000 rupees, and the total is 2000 rupees. So where is that 1000 rupees which was available earlier, as in the earlier sum was 1000 and now the sum is 2000. So that means we can say the system is in in an inconsistent state. So in order to we can say in order to prevent the system from this inconsistency, we need to have this rollback and commit. Now how this rollback and commit is going to save us in this particular situation? Now for example, 1000 rupees had been deducted from account A, but not added to the account B, and the system has crashed. Now when the system is going to kind of say switch on, or when the system restarts, the rollback will automatically occur, and it is going to restore the system to its previous state. That previous state is account A is having 2000 and account B is having 1000. Why this rollback has been occurred? Why this rollback has occurred? Because your we can say commit has not been done. So till the time we have not committed the work, transaction effects will be rolled back. So deduction of 1000 rupees from account A has been rolled back, and now your account A is having 2000, your account B is having 1000, and the system is having a consistent state which was earlier available, that means having a total of 3000. Now here one thing which is very important here is we have already seen that by either committing the actions of a transaction after all its steps are completed, we are going to ensure that the transaction, if all these steps are completed for a particular transaction, the commit statement should go on, or we are going to roll back all its action in case the transaction could not complete all of its actions completely and successfully. And that we have seen in just the example that deduction of amount has happened but not the addition. That means all the steps are not successfully completed, then it is going to roll back. Now with this commit and roll back, that is by either committing the actions of a transaction after all the steps are completed, or rolling back the actions of a transaction in case it is not completed, or in case it has not completed all its actions successfully. We are we have created one we can say concept here, which is the transaction is actually an atomic or indivisible entity. So if the transaction says that the account has to be debited from one amount has been amount is to be debited from one account and is to be deposited into another account, this whole transaction is indivisible. We cannot say we are going to perform the deduction step and it is okay if we are not going to perform the addition step. No, it is not going to happen. With the help of this transaction and committing and rollback steps, we have established the abstraction of a transaction as being an we can say atomic entity. With this we can say either all the effects of the transaction are reflected in the database, or none of the effects has been will be reflected and all will be rolled back. So either it is to be committed completely done, or it has to be rollback. It is not a situation that half done and half not done. That situation is we can say not acceptable, which is not desirable, because this is going to leave the database or will leave the database in an inconsistent state, as I have just explained. Now, with this concept of transaction and the fundamentals of rollback and commit, let us try to incorporate here one more topic, which is small but important, is about the integrity constraints. Now, you have already seen the integrity constraints in the previous lecture, that the integrity constraints ensure that the changes made to the database by the authorized user do not result in the loss of the data consistency, or we can say integrity constraints are are the tools which guard against the accidental damage to the database. And now, what all could be the integrity constraints? The integrity constraints could be an instructor's name or a particular field cannot be null, a particular field cannot have the same values. For example, no two instructors can have the same instructor ID, and instructor name cannot be null. Or other integrity constraints could be a budget of the department must not be must be greater than $0, and every department name in the course relation must have a matching department name in the department relation, and so on and so forth. So, all these types of integrity constraints we are there. How are we going to establish this integrity constraint? That we have seen in our previous videos, as these integrity constraints are usually identified as part of database schema design process. That means whenever we are kind of creating the relation, that means whenever we are kind of designing the schema, on that particular moment, these are these integrity constraints are usually identified and implemented. That means these are declared as the part of create table command, which is used to create the relations. What point I am trying to make here is the kind of implementation of integrity constraints while create table, that we have already seen. Today we are going to see the usage, or we can say implementation of integrity constraints after the relation has been created. That means these integrity constraints can also be added to an existing relation by using alter table command. So, alter table is there to kind of we can say change the schema design. So, alter table, then the name of the table and whatever constraints we want to add and then that constraint. So, that so for example, we have, in addition to primary key constraints, we have already seen how to put a primary key constraint. There are number of other integrity constraints which can be included either in the create table command or in the update table command, and these integrity constraints are not null. This we have also seen. Then unique constraint is there, and also we have one more integrity constraint, or one more we can say technique to implement integrity constraint, that is check. So, for example, we can say alter table instructor add name not null, or name varchar 20 not null while creating the table, that is also fine. Then there is a numeric field which is budget, and the total 12 digits, 2 digits after the decimal point. So, budget numeric 12 2 as the specifications of the data type, not null. If we want to give a constraint that this particular feature or this particular field should not have should be unique, that means no two data in this particular field should be matching, we can give that with a unique unique constraint, unique, and then the names of the candidate key, that means unique. For example, AJ1, AJ2 till AJM where AJ1 to AJM form a candidate key. So, by ensuring this particular constraint, this particular integrity constraint, we can say that there are no two tuples in the relation can be equal on all the listed attributes. So, in this way we can have a unique constraint, we can have a not null constraint. We can also have a check constraint, as I have just told you, that apart from primary key we can have not null, we can have unique constraint, we can also have check constraint. So, check, and then within the bracket we have one particular predicate which is to be satisfied by every tuple of the relation. So, for example, we are going to put a clause of check and within the bracket budget greater than 0, while we are creating the table command for the relation department. This is going to ensure that value of budget should be non-negative. So, let us try to kind of see all these constraints or implementation of all these constraints with the help of a create table as of now. So, create table section, we have seen course ID, then section ID along with the data types of course, then we have seen semester, then year, building and room number, time slot ID is also there. Apart from that, last 4 lines are specifying the constraints. We have seen primary key, course ID, section ID, semester, year. So, the combination of all these 4 fields, which is course ID, section ID, semester and year, should be we can say must be unique and not null as well, because we have defined it as a primary key. And in order to see that the value of semester should not be anything other than the fall, winter, spring, summer, because these are the only possible values of semester. Either it could be a fall semester or a winter semester, a spring semester or summer semester. So, we have written at the end check semester in and within the bracket fall, winter, spring and summer. So, we have given a list in which the semester has to be checked, and if the value of this semester while entering the data is not following any of the is not among any of these 4, it is not going to we can say insert the data. So, here in this create table we can say command, we have seen primary key which we have already seen earlier, that is nothing nothing new for us, but yes, check constraint is here which says check semester in fall, winter, spring and summer, basically a list, or we can say check budget greater than 0, that is also a possible check constraint. So, any of the predicate we can give here inside the brackets or inside the check condition we can say. So, in this way we can ensure the integrity constraints. Now, please recall, apart from integrity constraints, we have also seen a bit of referential integrity, and here I am going to add something to that referential integrity. But before that, let us recall what is referential integrity. So, referential integrity is about we can say foreign keys in which the values of a particular field in one relation are referenced with the other. So, for example, we have one particular parent table in which the department name is there, and if we are adding the instructor name in another table which is instructor, so department should be any of the value which is available in the department. So, for example, in the departments we have computer science, maths and let us say English. So, we cannot add any instructor which is of department Hindi, because that Hindi department is actually non-existing here. So, this relation is actually implemented with the help of referential integrity, which ensures that a value that appears in one relation for a given set of attributes also appear for a certain set of attributes in another relation. And the example of department name here, of department name which I was just describing can be taken here as department name varchar 20 references department. So that means wherever I am going to add this department name, for example, create table faculty, instructor ID, name, department name, varchar 20 references department. References department, that means whatever value you are going to insert inside this field, which is department name, that should refer the values from the department, from the table department. So when a referential integrity constraint is violated, the normal procedure is to reject that action that is causing a violation. That means if I am going to kind of a making an update from computer science to Hindi, and Hindi department is non-existing, in that situation, that we can say that request is violated. However, we can say a foreign key clause, which is about this references, can specify that if a delete or update action on the reference relation violated the constraint, so instead of rejecting that action, the system must take steps to change the tuple in the referencing relation to restore the constraint. So it is not always the rejection, but yes, the tuple can restore the constraint, and that can be done with the help of the term cascade. We can say create table codes, whatever we whatever extra fields we need to have, foreign key department name, which is coming from the references of department, and we have specified on delete cascade and on update cascade. Now what is happening? If a delete or if an update is going to violate this constraint, then the system will not reject the delete or update. Instead, the delete or update cascades to the codes relation, deleting or updating the tuple that refers to the department that was deleted. That means the changes will be reflected in the we can say parent parent table, and the change or update will be permitted here also. So on delete cascade is important in this situation if we want to cascade the effect to the parent table also. So here in this lecture, we have seen the concept of transaction. We have also seen the actions of rollback and commit, and apart from that we have seen integrity constraints and referential integrity constraints and entity integrity constraints. Here is a list of references which is being used for the preparation of lecture. Hope you had a fruitful learning in this one. Thank you for watching.